when you're using a force at a very high speed. The force itself does not affect speed in a Newtonian way. And that generally works better, because then you can do things like
I have no idea what he's talking about.
transform the electromagnetic force
Uh-huh.
or the gravitational force and get some useful things out of that. Like you find that the electric force is just a relativistic transformation of the magnetic force.
How do you transform force?
You use a stress energy tensor and you apply
What is a
Lorentz
stress energy
transformation.
tensor?
It's basically you make a matrix. You know matrices? You know, an array of numbers. You put a bunch of field information in that. So you put the electric field components in some of them, and you put the magnetic field components in
But
some
like
of
the
them.
spin and the voltage and all that stuff?
More like, how would I use it? Do you know how the electric field works?
No.
Okay, well, at every point in space, there's a little arrow that points in some direction. You can say that arrow is pointing a little bit in this direction, a little bit in this direction, and a little bit in that direction, which are 3 different directions. They're all perpendicular, like this.
Right.
And you say, you know, one's in the x, one's in the y, one's in the z. So now you've turned one field, which is a little arrow at every point in space, into 3 numbers at every point in space. The magnetic field behaves the same way, and then you throw in some other values too that are more abstract, and you end up with an array of values of the fields that have been modified slightly to be balanced, because they need to balance each other out in certain ways. And that array of numbers you can call a tensor, and you can do transformations on that by multiplying it by other arrays, which transform them all at once, and you get relativistic transformations. So you have the Maxwell stress energy tensor, which you can transform via a Lorentz transformation, which is a relativistic transformation. And you get what the fields would look like if you're moving at 1,000 miles an hour.